Welcome to Python Data Visualization for Beginners. In this tutorial, we will turn raw data into clear, beautiful charts using Matplotlib, Seaborn, and Plotly. No prior experience needed. Let's get started. So, you've got some data, and you want to make sense of it. Numbers in a spreadsheet are fine, but a well-made chart tells a story instantly. Imagine you have 1,000 rows of sales data. You could stare at it for an hour, or you could plot it in 3 lines of code and instantly see the trend. That is the power of data visualization. It helps you spot patterns your brain would miss in raw data, communicate complex insights in seconds, and tell stories that your audience will actually remember. Watch as we transform a block of raw numbers into a clean bar chart that reveals the story at a glance. Before we write any code, let's set up our environment. Open your terminal and run pip install Matplotlib Seaborn Plotly pandas. That's 4 libraries, and they cover everything we need. Matplotlib is the foundation, the most fundamental plotting library in Python. Seaborn builds on top of it for statistical charts. Plotly adds interactivity, and pandas handles our data. Once these are installed, you're ready to create your first chart. Let's create your very first chart in just 6 lines of code. We'll use Matplotlib, import it as PLT, which is the standard convention. First, we define 2 lists, x with values 1 through 5, and y with values 10 through 50. Then we call plt.plot with x and y to draw the line. We add a title, label the axes, and call plt.show to render the chart. Watch how the execution moves through each line. The import loads the library. The variables store our data points. The plot function connects them with a line. The title and labels make it readable. And finally, show opens the chart window. Simple, but it works. This is the foundation everything else builds on. Now, let's make something more practical. Line charts are perfect for tracking change over time. Here we have monthly sales data for 6 months. We use pandas to create a data frame from a dictionary, then plot the months on the x-axis and sales on the y-axis. Notice the marker parameter set to O, which adds a dot at each data point, making it easier to read exact values. The color is set to steel blue, and we add a grid with alpha 0.5 to make the grid lines slightly transparent, so they don't overpower your data. Watch as the line draws from January to June, showing a clear upward trend. Sales started at 1,200 in January and grew to 2,800 by June. That's a story your audience can understand in a single glance. Want to compare different categories? Bar charts are your go-to. Here we're comparing the popularity of 5 programming languages in 2024. We pass the category names and their popularity scores to plut.bar. The color is set to coral, and we add a black edge color, which gives each bar a crisp outline and makes the chart look much more polished. Watch as each bar springs up, showing JavaScript leading at 63, followed closely by Python at 58. Java, C++, and Go trail behind. The height of each bar makes the comparison instant. You don't need to read the numbers to see which languages are most popular. Scatter plots help you find whether 2 things are related to each other. For example, do people tip more on bigger bills? We use Seaborn's scatterplot function with the built-in tips dataset. The x-axis is the total bill amount, the y-axis is the tip, and here's the cool part. The hue parameter colors the dots by time of day, lunch or dinner. This lets you compare 2 things at once without any extra work. Watch as each dot appears on the plot. The blue dots represent lunch. The pink dots represent dinner, and you can see a general trend. As the bill amount increases, the tip tends to increase too. The trend line confirms this positive relationship. This is the kind of insight that would be much harder to spot in a spreadsheet. A heat map uses color intensity to show values in a grid. It's great for spotting which variables in your dataset are related to each other. Here we calculate the correlation matrix from the tips dataset using the core method, then pass it to Seaborn's heatmap function. The anit parameter adds the actual numbers on each cell, and comp coolwarm gives us a red to blue color scale. Watch as each cell fills in, values close to 1.0, like the diagonal, mean a perfect positive relationship. Values near 0 mean little to no relationship. Notice how total bill and tip have a correlation of 0.60, a moderate positive relationship. The color intensity makes these patterns instantly visible across the entire dataset. Default charts get the job done, but a few tweaks make a huge difference visually. Let's look at the key styling parameters. First, Lyrosin set to double dash gives us a dashed line instead of solid. The color medium sea green replaces the default blue. Line width 2.5 makes the line thicker and more prominent. The marker set to S gives us square markers instead of circles, and marker size 8 controls their size. For the title, we increase the font size to 18 and set font weight to bold for emphasis. We also style the axis labels and add a dotted grid. These small changes transform a basic chart into something that looks clean and professional. Always remember, good styling isn't decoration, it's communication. Everything we've built so far is static. But what if your viewers could hover over data points, zoom in, or click to filter? That's what Plotly does. Here, we create an interactive pie chart showing fruit sales breakdown. We import Plotly Express as px, define our data with fruit names and counts, then call px.pie with the values and names parameters. When you call fig.show, it opens an interactive chart in your browser. You can hover over any slice to see the exact value. Click a slice to hide it, and even download the chart as an image. Use Matplotlib and Seaborn for scripts, reports, and quick analysis. Use Plotly when you want to share charts online or build interactive applications. Here's a quick reference table you can use as a cheat sheet. When you need to show change over time, use a line chart. When comparing categories, go with a bar chart. For finding relationships between two variables, a scatter plot is your best choice. To show part to whole relationships, use a pie chart. When you need to visualize correlations across many columns, a heat map is the way to go. And for comparing distributions across groups, consider box plots or violin plots. Keep this table handy whenever you're deciding which chart type to use for your data. Once you're comfortable with these basics, here's what to explore next. First, learn pandas.plot, which lets you plot directly from a data frame with one line of code. Second, master subplots using PLT DC chubplots to display multiple charts side by side. Third, check out Streamlit, which turns your Python charts into a shareable web app in minutes. And fourth, look into Plotly Dash for building fully interactive data dashboards using only Python. Each of these tools builds on what you've learned today and takes your data visualization skills to the next level. You've made it through the complete tutorial. Here are the key takeaways. Matplotlib is the foundation. Learn it first. Seaborn makes statistical charts easier and prettier. Plotly adds interactivity for sharing in dashboards. Always label your axes. Never make your audience guess. Use color with purpose, not just decoration. And start simple, then layer in complexity as needed. Data visualization is one of those skills that immediately makes your work more impactful. Now go build something. If you found this helpful, like, subscribe, and share it with someone who needs it.